Good morning. I hope everyone is doing well. So today we are going to go to Unit 12, Day 7. We are only going to do the car loan part of it. We are going to do the mortgages in another day. So for car loans, this is actually pretty interesting because probably 90% of us will eventually have a car loan at some point. So it is interesting to figure out where they get their payments from and how much you can afford and stuff like that. So the formula that we will be using is AP equals R, parentheses, 1 minus, in parentheses, 1 plus I, close the parentheses, raised to the negative n over I. Okay, so it's kind of similar to the one we did the other day where we were doing annuities. And like that's a savings account. So you're putting money into it. So that was a different formula. So if you have to answer questions and it deals with you putting money away and how much you'll have after a certain amount of time or how much interest you'll earn, that is the other formula that we did the other day. If you need to figure out a payment or how much you can afford, like a car loan or a boat loan or a motorcycle, anything like that, you're going to use this formula. So the variables are pretty similar. The AP on the left side is just your final amount or how much your loan will be for. So if you want to buy a $10,000 car and figure out how much your payment is, your final amount or your loan amount would be $10,000. That would be on the left. Moving on, if you look at R, capital R is the same thing. It's your recurring payment. So normally with loans, you pay it monthly. So normally your recurring payment would be a month, how much you can afford a month. Moving on, we have I's in 2 spots. So I again is your interest rate. Remember, you need to always move your decimal 2 places to the left. And then normally, since it is a car loan or some type of loan that normally you do pay back monthly, so normally your interest here is going to be divided by 12. Just like we did with the annuity payments, everything must match. Okay, so if you're dealing with monthly, which mostly these ones are usually going to be monthly, so usually your interest rate is going to be divided by 12. Okay, and then your N is your number of payments. So your number of payments is just going to, again, probably be the number of months that you are paying your loan off. So if you do 5 years, you would do 12 times 5, which is 60. Okay. All right, so we're going to start with the first one. So if you are working in the packet, I might have changed the numbers a little bit just because, again, my packet didn't have the numbers. So a college student wants to buy a car and can afford to pay $250 per month. Okay, so we know that this college student can pay $250 a month. If she plans to take out a 5-year loan with an annual interest rate of 4%, what price car can she buy? Okay, so we're going to always write down your formula first with nothing in it. So we have 1 minus 1 plus I to the negative n over I. If you'd like to write down what all your variables are on the side, go right ahead. Okay, so AP is what we're looking for. That's how the price of the car that she can buy. So that's how much we want to figure out. Okay. Now we have R. So her recurring payment is monthly. Monthly, she said that she can afford $250. So her R is $250. Again, remember that is a month. So right now, our whole problem should be in terms of months. She's going to take out a 5-year loan. So that is her number of payments. So remember, 5 is in years. She's not only going to make 5 payments, she's going to make 5 times 12 months, which means she's going to make 60 payments. And then we have I, which is our interest rate. So her interest rate is 4%. So as a rate, you would move your decimal to change it to 0.04. But again, that's the annual interest rate. All these numbers are monthly, so I need to divide that by 12. So there's my numbers. I'm going to plug into the formula. So AP equals, my recurring payment is $250, big parentheses, 1 minus open up parentheses again, 1 plus. Your I, we said, was your interest rate, so 0.04 over 12. Close the parenthesis. Raise it to the negative n, so negative 60. And then in the denominator, you have another interest, or I, which is 0.04 over 12. So if you notice, these formulas do get a little crazy with the amount of fractions and parentheses. So if you have, well, the calculators from class would have done these perfectly with the alpha y equals. If you have the app with the calculator that does it for you, and you can put in alpha y equals and put in these fractions, you should be okay. If not, you have to learn how to do it and kind of go step by step. So I'm gonna work inside the parenthesis and work my way out, okay? So first thing I notice here, I have a parenthesis, 1 plus 0.04, and it's raised to the negative 60 power. So that's what I'm gonna do first. So I'm gonna take the 0.04 divided by 12 right here, right? I'm gonna add 1 to that number. And then I'm gonna raise it to the negative 60, okay? So now, right now I have this number, 0.81900 dot, dot, dot. Now I need to do 1 minus that number, not minus 1 from the number you have in your calculator. So you need to, in your calculator, press 1 minus, and now you gotta take that whole decimal and put it in there. So usually if you press second answer, the whole decimal will pop up. So now I have my numerator, is 0.18099 dot, dot, dot. Now I have the whole top, I need to divide it by, parentheses, 0.04 divided by 12. Okay, so then you should end up with your whole parenthesis now being 54.29 dot, dot, dot. So now I just times that by the payment, the 250, which means the amount that she can afford is $13,570, we'll round it up, 5. Okay, so normally they don't really tell you what to round to. We'll just round to the nearest whole number for all of these. Okay, so $250 payment for 5 years at an interest rate of 4% means that she can purchase a $13,575 car. Okay. Okay, the second one. Okay. So again, I took this from the packet. I'm not sure, the numbers might have been there for this one. So again, if they're not, just go by the one that I'm using. So Fran wants to purchase a new boat, around $6,000. She creates a budget and thinks that she can afford $250 every month for 2 years. Her bank charges her 5% interest per year, compounded monthly. Now, in the other question, it said 4% annual interest rate. And now in this one, it's saying 5% interest per year, compounded monthly. They're the same exact thing. So whether it says compounded monthly and whether it doesn't, if you are putting in monthly payments, you will have to divide by 12. Okay, so sometimes they do give you that extra kind of clue that tells you, okay, I need to divide that interest by 12. So what is the actual monthly payment of Fran's loan? So this one's a little different. We are not doing the $250 yet. Okay, we're figuring out what her R would be if she did buy a $6,000 boat. Okay, so now again, we always write down the formula. So we have R, big parenthesis, 1 minus, parenthesis, 1 plus I to the negative n over I. Okay, so for this one, we know that she is buying a $6,000 boat. Okay. All right, what else we got? We don't know R for part A. Yes, she can afford $250, but we want to know what her actual monthly payment would be. Okay, so the $250 for the first part, we don't know. Okay, the $250 doesn't apply to the first part A. Then we have our N, which is our number of payments. So she's doing this for 2 years. So 2 times 12 months means she would be making 24 payments. And her interest is 5%, so that is 0.05 over 12. Because again, everything wants to be monthly to match up. So 6,000 is going to go on the left-hand side. We do not know R for part A. 1 minus, 1 plus. Our interest rate is 0.05 over 12. Our negative N is negative 24. And then our interest rate is 0.05 over 12 on the bottom. Okay. So we have 6,000 equals R. Now we got to figure out what that whole entire parenthesis is. Okay. So same way I did it before. I'm going to do 0.05 over 12. I'm going to add 1 to it. I'm going to raise that to the negative 24. I'm going to do 1 minus that big decimal. I'm going to divide that by 0.05 over 12. So this whole big parenthesis actually comes out to 22.79 dot, dot, dot. So this one's a little different because we have the number over here. So if I want to get R by itself, these two are being multiplied. I'm going to just divide it out. Remember, do not round too soon. So you should be doing 6,000 divided by that whole entire 22 decimal number. So our recurring payment for a $6,000 boat would be $263.02. So we're going to leave it as $263. Okay, so it's not far off from her payment, $250, $263. Okay, so $13 off. But if she can only afford to pay $250 a month, what's the most expensive boat that she can buy? So part B brings us back to the one we did like before. Okay, we don't know now what AP is going to be. Our recurring payment, we want to use her $250. Our N is still going to be 24, and our I is still going to be 0.05 over 12. Okay, so now we're going to go back to the formula. We are now going to plug in 250 for R. The whole parenthesis is actually going to stay the same. 0.05 over 12, the negative 24, all over 0.05 over 12. So remember that 22.79 number, which was our whole entire parenthesis? If you have it in your calculator accessible, because remember, we don't want to round it too soon, we would just times it by 250. Mine, of course, is not there, so I need to plug the parenthesis in. Add 1. So 22.79 was the number, so now I'm going to times it by 250, which means that the boat she can afford is $5,698.4, so we'll leave it as $5,698. So close to a $6,000 boat, but a little less because she only wants to pay $250. Okay, if she did get the $6,000 boat, her payment would be $263, which is $13 over her budget. Okay. All right, so I will post for you the 2 questions that I want you to try, and then take a picture of your work just like you've been doing, and it will be due by Thursday morning. That will be already your week 3 effort grade. So it's just going to be those 2 questions. Okay, I'm trying to keep it nice and simple for you guys. And then on Thursday morning, I will post your assessment number 2. Okay, I hope everyone has a good day, and I hope everyone is staying safe and well. Bye, guys.